Okay, let's take a look at how you can use that. Okay, let's say I asked you to find the area of a regular pentagon. And let's say this regular pentagon also has a side of 10. Okay, so when we start our problem, area is equal to 1/2 SAN to begin with, our formula. And we can plug in what we know. 1/2, what's the length of each side? 10. We don't know the apothem yet. What's the number of sides? Pentagon, so 5. Okay, so let's draw in, sketch our one reference triangle. As with all these reference triangles, it's isosceles. So when we draw in our apothem, we need to solve for this apothem. Okay, what's that apothem going to do to the base of 10? Cut it in half. Okay, so here's the right triangle that we're going to use to find A. Okay, in order to find A, we need to either find this other length, this hypotenuse, so you could then use Pythagorean theorem, okay, which we're not going to be able to do, or we need to know what one or both of these angles is. If we can find one of them, we can find the other. Okay, how do you think we might be able to locate or identify what either this angle or this angle would be? The two things that I talked about up here, right? What is each interior angle of the regular pentagon going to be? Each angle is 108. You found that in your sketchpad activity, okay? Or you could use the formula. And so if you cut that in half, what does that mean this angle down here is going to be? 54. So if you do it this way, the way that you could solve for your A value is you have an angle of 54, you have the side opposite that, and you have the side adjacent to that. Which trig ratio relates opposite and adjacent sides of a right triangle? No? No? Tangent. There we go. Okay, so we have the tangent of A, or the tangent of 54 is equal to opposite A over adjacent 5. If we multiply both sides by 5, we have our apothem. So the tan of 54 times 5. Okay, so you can use right triangle trig to find this. Now there's an alternative to this. Okay, let's think about how many steps it took to find this. Okay, so in order to find this angle of 108, how many used this first method versus the second method? Which one? Second method. Okay, so if you're using the second method, which probably is a little bit quicker, you would take 360 divided by 5. Okay, 360 divided by 5 is 72. 108 minus 72, or I'm sorry, 180 minus 72 gives you 108. Half of 108 gives you 54. That's 3 steps, right? Find the exterior angle, find its supplement, cut it in half. Okay, now, if you used this method too and found the exterior angle, well, what did we already find is the relationship between the exterior angle and this vertex angle? They're the same. So what do you know this whole angle is going to be? 360 divided by 5, so it's 72. So you can just cut that in half, save you one full step, because now that's only 2 steps. So you know that this angle right here is going to be 36. So instead of using 54 and the opposite and adjacent sides, we could have used 36. We have a side opposite and a side adjacent. We're still using the tangent ratio, only this time it would be the tangent of 36 is equal to opposite 5 over adjacent A. Multiply both sides by A, gets rid of the fraction. Isolate your A completely, so you'll divide both sides by the tangent of 36. And so there's your other possibility. We could have also used the value 5 over tan of 36 in place of this red number. Okay, either of those will work. They both identify the length of that apothem. They both can be plugged into the area formula. Sure. Yeah, I'm recording it. Okay. Is there questions on that? I know it's a little bit multi-steps. It combines some of the material from previous sections and chapters as well. But do you guys kind of see how that works? Okay, this is true for any regular polygon, so regular decagon, regular octagons. You're going to go through these same steps of create your reference triangle, draw in the apothegm, cut the base in half, and then use the right triangle that's formed there. You're always going to use the tangent ratios because those are going to be the measures that are involved.